Do you know how gasoline is actually produced at a refinery? Refining facilities in the oil and gas industry often include blending units, or product mixers, designed to combine multiple streams in precise proportions to produce a required finished product. The screen shows a simulation model built with the Petroleum Refining Library on the AnyLogic platform. It demonstrates how a product mixer can be used to produce A95 gasoline. The model receives 6 component streams, fractions with initial boiling points of 50, 85, and 100 degrees Celsius, light reformate, heavy reformate, and isopentane. These components are fed into the product mixer, where an optimization algorithm automatically determines the optimal blending ratio for producing on-specification A95 gasoline. To help the blend meet all applicable fuel specifications and regulatory requirements, the model can also use a balancing additive, methyl tert-butyl ether, or MTBE. The product mixer automatically determines the required MTBE dosage to achieve the target octane number, while keeping the blend within all specified composition limits. MTBE has a high octane number, typically above 100, but its use is limited by restrictions on oxygen and ether content. The optimization therefore balances its octane contribution against these compositional constraints to produce a compliant gasoline blend. The model also includes a production capacity constraint of 1,800 tons per day. Petroleum Refining Library allows the operator to control individual component flow rates in real time, adjust blending parameters, and immediately evaluate their impact on the final product. The upper section of the model displays the key quality specifications for the finished gasoline, including octane number, vapor pressure, benzene, aromatics, sulfur, oxygen, and ether content. These specifications are defined by the applicable fuel standards and may vary depending on the product grade and season. In Petroleum Refining Library, these specifications are maintained in a dedicated database and automatically loaded according to the current season. This allows the simulation to account for seasonal requirements and continuously check whether the resulting blend meets the required specifications. Now, let us look at the properties of the individual blend components. The first stream is a light fraction boiling up to approximately 85 degrees Celsius. It has a relatively low octane number, a read vapor pressure of about 82 kilopascals, and a sulfur content of approximately 13 ppm. Isopentane, on the other hand, has a higher octane number of 87, but also a very high read vapor pressure of around 180 kilopascals, and a sulfur content of approximately 22 ppm. As these properties demonstrate, none of the individual components can satisfy all A95 gasoline specifications on its own. The product mixer therefore determines the optimal combination of available streams, and, when necessary, adds the balancing additive to achieve the required product quality. While the key properties of the streams, such as octane number, vapor pressure, and sulfur content, are stored in the database, operational parameters, such as flow rates, can be changed dynamically during the simulation. For example, if we reduce the flow of the 0 to 85 degrees Celsius fraction, the optimization algorithm recalculates the blending ratio, and A95 gasoline can still be produced. However, if the isopentane flow is reduced to 0, production becomes impossible because the remaining components can no longer satisfy all product specifications simultaneously. This is where the flexibility of Petroleum Refining Library becomes particularly important. During the simulation, the operator can dynamically change the blending recipe, seasonal specifications, production targets, maximum product rates, and balancing additive requirements. The optimization algorithm continuously evaluates the available streams and determines the best feasible combination for producing on-specification gasoline while respecting all operational constraints. You can find a live demonstration of this model on our website, where you can explore the product mixer and experiment with its operation in real time. In the next part, we will demonstrate another approach to operating the product mixer, one based on historical data from previous blending operations. Visit our website to explore the model and see how Petroleum Refining Library enables dynamic gasoline blending and real-time optimization. Thank you for watching.